All right, we're going to start by talking about a reference angle. So a reference angle is the positive acute angle that that the terminal side of an angle in standard position makes with the x-axis. Okay, so let's plot an angle in a 160-degree angle in standard position. So if you remember, that means the vertex is going to be at the origin. One of the sides, the initial side, is always going to point straight to the right. The other side, it depends what the angle is. So if it were a 90-degree angle, it would be pointing straight up. But this is more than 90. It's less than 180 though, right? 180 would look like this, so it's going to be closed a little bit from the 180 angle. So I'm not going to measure this out, but you could measure it out with a protractor. It's going to end up something like that, right? That's a 160-degree angle in standard position, okay? Now the reference angle for this, let's use this definition that we created up here. It's the positive acute angle that the terminal side of an angle in standard position makes with the x-axis. Okay, so here's the x-axis. So yeah, here's an angle that that's made with the x-axis, but it's not acute, right? That one's obtuse, the one that I have in pink there. So the reference angle is going to look like this. Okay, so yeah, it's an acute angle that's made with the x-axis and the terminal side. Okay. And since this is a total of 180 degrees, the pink and the green angles together, and I've got 160 spoken for up here, that means I've got another 20 degrees to go to get to the x-axis. Okay, and that means this is my reference angle. My reference angle for 160 degrees is 20 degrees. Okay, so sometimes it's just what you have to add to the angle to get to 180, but that's not always the case because you might end up with your terminal side being below the x-axis. So it kind of depends on the situation. So it's not quite so simple as just what do I have to add to this to get to 180. Sometimes if it's a number less than 180, that's going to work, but not if it's a number more than 180. Okay. Or if it's a negative angle, that's not going to work either. Okay, so 210 degrees. First, I'm just going to plot this. So thinking there's my initial side. Here's my vertex. Let's see, 90 degrees. Going to the left would be 180. If it's going straight down, that would be a total of 270 because 90 times 3. So less than 270, but more than 180. It's going to end up somewhere in this quadrant, and it's not really that important that you plot it accurately, super accurately. You just really need it in the right quadrant. So I know it's going to be between 180 and 270, right? So you know this would have been 180, and this is 270. Okay, so it's somewhere in there. All right, and that let's plot our reference angle. So some people are going to put it right here. I see that happen a lot. But I need to make it not with the y-axis. This is the y-axis, right? I need to make an angle with the x-axis. So that means this is going to be my reference angle. Okay, I'm just going to put little theta there. That's the angle that I'm talking about for my reference angle. And I got to figure out what that equals. So I'm kind of just thinking, how far do I have to go to get to the x-axis? So I went 210 degrees. So I'm thinking, how far did I go past 180? Well, I went, that means I would have gone 30 degrees past 180, okay? And often I'll also see people say that this is negative 30 because it's below the x-axis, and I understand why people are thinking that. But we're just thinking if I measured this angle with a protractor. So the reference angle is always positive. So if you go back to this definition, it's the positive angle. It's always positive. It doesn't matter where the angle is. In this case, it's always going to be positive. So my reference angle here is 30 degrees, not negative 30, 30 degrees. Okay. All right, and on this last one, let's first plot a negative 280-degree angle. So there's my initial side, and then instead of going up like I would for a positive angle, I'm going to be going down. Okay. So I'm kind of just counting. There's 90 degrees. This would be 180 in the negative direction. This is going to be 270. Hey, I'm almost there, right? I'm negative 270 right now. Just another 10 to go. So just a little bit further. And then there's what my angle is going to look like in standard position. Okay, I guess on this last one I should have shown that I went around that direction. I forgot to do that. Okay, so a negative 280 degrees in the negative direction. And again, I'll see people, since you're only 10 degrees away from the y-axis, I'll see people put their reference angle there and say that their reference angle is 10 degrees. That's incorrect. You always have to do this with the x-axis. So this terminal side, I'm thinking, what's the quickest way to get to the x-axis? Well, that would be going straight down to it. Okay, so I have to figure out what this angle is. Okay, and I want the positive angle. I know it's negative 280. Excuse the bell there. I know that's negative 280, but I want to know what the positive angle is. So if I went in the positive direction, well, hey, I'm going to be 10 degrees shy. This little bit in here was 10 degrees, right? We went 10 degrees past 270. So if I'm going in the positive direction, that means I'm 10 degrees shy of 90 degrees. So I know that this is going to be 80 degrees then. Okay, so my reference angle here then is 80 degrees. Okay, on the next page then, we've got this problem. We've got a negative 4, 5 is a point on the terminal side of this angle. And we're going to find sine, cosine, and tangent from that. Okay, so what you want to do first is sketch the angle in standard position. So I've got a graph right here. I've already got the point negative 4, negative 5 plotted on there, but if it wasn't, you'd plot it, right? That's this point, that's the point P. And so if I put this in this angle in standard position, there's the initial side. The terminal side I know is going to go through point P, and it'll also, my vertex is at the origin, so there it is. Okay, so that's my first step. Second step, I'm going to mark the reference angle as theta. Okay, so the reference angle, if I drew that in, I'd be making an acute angle with the x-axis and the terminal side. So here is my reference angle, and I'm going to call that theta. Okay. Next step, I'm going to draw a vertical line from point P to the x-axis. Okay, so here's a vertical line, right? And I'm going to draw a little segment just like that. Okay, and now what I have here is a right triangle. And that's super useful because that means I can use the Pythagorean theorem if I know 2 of the 3 sides. Okay, so now I've got a right triangle with vertices at point P in the origin, right? All right. Yeah, and now I'm going to find the side lengths. So I can find 2 of the side lengths just from the coordinates, because from the origin here I've gone 4 to the left and 4 down. Okay, so since I'm going left, I'm going to call that negative 4. And since I'm going down, I'm going to call that negative 5. Okay. Now, I don't know the hypotenuse yet, but I can figure that out by using the Pythagorean theorem. Okay, so I just called that C in honor of the Pythagorean theorem, so I'll do a little side problem here. And the fact that A and B are negative, it doesn't really matter because we're going to be squaring. Negative 4 squared is positive 16, right? And since when I square these negatives, they come out positive, yeah, I'm not going to be taking, it's not going to be imaginary, right? I'm going to get always get square root of a positive number. Okay, so I'm going to take the square root now of both sides. Now, algebraically, I could say positive or negative root 41, but I'm talking about a distance here. And even though I'm going down and to the left, the hypotenuse is always going to be positive. Okay, so I'm going to call this root 41. Okay, and if I want to put that in simple radical form, but there's no, that 41 is a prime number, so it is in simple radical form. Okay. Now I can use the coordinates to find, or I can use SOHCAHTOA I can use the formulas to find sine, cosine, and tangent. Okay? So now when I'm looking for the sine of theta, well, that's opposite over adjacent, or opposite over hypotenuse, rather. Okay? And looking at this triangle, well, hey, opposite is going to be -5, and the hypotenuse is root 41. Okay? And I still need to put that in simple radical form. I have a radical in the denominator, so I'm going to do this to get rid of that radical. So this will be -5 root 41 over 41. Okay? So then we'll repeat the process with cosine and tangent. So I got adjacent over hypotenuse here. So yeah, this is my hypotenuse. This would be my adjacent. It's always in relationship to the reference angle. Okay, so adjacent is going to be -4, and hypotenuse is root 41. And again, want to go simple radical form. My pen is dying here. I have to switch to this one. Okay, and then tangent, opposite over adjacent. So the opposite here is -5, adjacent's -4, and then that simplified to 5/4. Okay, and then yeah, then we found sine, cosine, and tangent. We could find the reciprocal functions as well. Okay, got a similar problem on the next page, so let's try another. We're going to find all 6 trig functions this time, but if you find sine, cosine, and tangent, you just flip them to get the other 3, right? So, got the point 4, -3 here. So, plotting here's the initial side, right? And the terminal side is going to go through point P. So something like that. Okay. And then it doesn't actually matter which way I went around. All of the coterminal angles are going to have the same values for the trig functions. So that's the beauty of a reference angle. So my reference angle here is actually just going to be right here, right? Because I'm making an acute angle with the x-axis. Okay. So then I'll make myself a right triangle from that, where the origin is a corner and point P is a corner, and then there's my right angle. Okay, and then I'm thinking about I want to find the sides of this triangle. So 4 right and 3 down. So this is 4, -3. Okay, and then I'm going to want to find the hypotenuse. So I could use the Pythagorean theorem. I'm noticing, hey, this is a 3, 4, 5 triangle. So if you did -3 squared plus 4 squared, it would equal 5 squared. This is going to come out to 5, but if you didn't notice that, just do the Pythagorean theorem, okay? And then we're, our position is over here at the reference angle. So we've got opposite, adjacent, and this would be the hypotenuse. Okay, hypotenuse is always positive, even if you're going down or to the left or anything. Hypotenuse is always positive, but the 2 legs could be positive or negative depending on if you're going left or right or up or down. Okay, and then we can set everything up. So sine. Thinking SOHCAHTOA here, opposite over adjacent. Cosine is going to be, why did I do opposite over adjacent? That's tangent. Opposite over hypotenuse is what I meant. SOHCAHTOA, and then adjacent over hypotenuse. Tangent is opposite over adjacent. Okay. So let's get these 3 first. Opposite, -3 over 5. That one's already reduced. Good to go. 4 over 5 for cosine. And tangent would be -3 over 4. Okay, and then I've got the reciprocals of these. So the reciprocal of sine would be cosecant. Reciprocal of cosine is secant. Reciprocal of tangent is cotangent. Since these are reciprocals, I can just flip them all upside down.
And sometimes if there's radicals involved, you might still need to put them in simple radical form after you flip them. But these, since I've just got integers as my numerators and denominators, I just flip them as they are. And there's the other three. Got all 6 of them. Okay? And that's all I got today. See you next time.